Good day, everyone. My name is Edentekhe Effiong. This research was supervised and carried out in collaboration with Dr. S.C. Nwanya and Professor O.V. Ekechukwu. Together, we worked on simulated energy performance of church buildings in Nigeria. To ascertain the efficiency of energy use, it is essential to carry out an evaluation of the energy performance of buildings. While energy performance of buildings has been very popular, especially in developed countries, very few studies have been carried out in church buildings, and little or nothing has been done in this area in Nigeria to the best of our knowledge. Most of the works done in Nigeria basically borders on public housing, hospitals, hotels, hostels, and residential buildings. Now, in 2010, Nigeria ranked number 1 in weekly church attendance in the world, according to Swambro. Most church buildings, like we know, consume a bulk of energy in the operation of sophisticated electrical equipment, musical instruments, electrical lightings, and fittings. With more churches building larger auditoriums and with its attendant population, it is expedient for energy audit to be carried out in such buildings so as to determine the energy efficiency and to also ensure that the comfort level of worshippers is not compromised. The purpose of this study was to investigate the current energy performance levels of the church buildings using an energy simulation tool known as eQuest. The specific objectives were: 1, to assess the energy consumption of major church buildings in Ekechukwu, Akwa Ibom State; 2, to estimate some of the energy performance indices in church buildings; and 3, to determine the quantities of energy usage and their consumption patterns within the location of the churches. The focus of this research was on investigating the energy performance of the major church buildings in Ekechukwu, Akwa Ibom State. The church buildings assessed were all purpose-built permanent buildings of the respective churches. In other words, all the churches that were used for this research were built specifically for worship services. Now, there is no central data bank where energy consumptions are periodically documented in Nigeria. Hence, the data used for this very research were gathered from primary sources, basically through questionnaire administration and church personnel interview. Now, let's take a look at some of the works that have been done prior to this research. In 2012, HUSCM worked on energy audit and energy management for church buildings in Hong Kong. In 2014, Bolofo Rush worked on the sustainable energy strategy for historic churches and cathedrals in the UK. And Terril in 2015 worked on the energy use and thermal comfort in religious facilities. Balonova et al. In 2015 worked on the performance simulation of the tower of an ancient church in Prague. In 2016, Ezema et al. Worked on the factors influencing operational energy performance and refurbishment of UK-listed church buildings towards a strategic management framework. We did feel justified to carry out this research because very little research had been carried out in the area of energy performance of church buildings worldwide. Also in Africa, and especially here in Nigeria, literally no work had been done in this area to the best of our knowledge. On the other hand, global warming or climate change is location-based. Therefore, work done in other countries does not reflect the situation in Nigeria. Now, what method did we employ in carrying out this research? A walk-through energy audit approach was taken. In other words, we visited the different churches and then we administered the questionnaires to the people that could best give us the needed responses. And then also we had personal interviews with the operators and the different individuals that could give us the best possible answers that will enable us carry out the research successfully. The church buildings assessed were all located in Ekechukwu, Akwa Ibom State. the energy performance assessment took into consideration all areas of energy utilization such as lighting, ventilation, cooling, refrigeration, and sound. All test data was subjected to analysis using eQuest building energy simulation software. eQuest performs simulations of the building based on walls, windows, glass, people, plug loads, and ventilation. It's important for me to state here that we had some difficulty in getting data for some of the sound equipment. So we had to resort to visiting sound equipment stores, and in extreme cases had to contact the manufacturer of some of the equipment for the power ratings. Now, let's go into the results and discussion. Now, on the sources of energy supply for Nigerian church buildings, we discovered that most of the churches depended on soundproof diesel generators for their supply of electricity. We also noticed that grid electricity supply was often infrequent and not reliable, as expected. And then some churches reported not having power supply at all for some days from the national grid. Energy demand of the church buildings in Nigeria showed that the sound equipment stroke instruments consumed the bulk of the energy supply, followed by the ventilation and cooling, and then the lighting demand. Now, let's go into the detailed discussion of the eQuest simulation results. Now, the data requirements for the eQuest simulation included general church building information, building footprints, building envelope constructions, interior constructions, the load occupied by activity areas, the HVAC system, that's the heating, ventilation, and air conditioning system, and the electric utility charges. Now, at this point, it's important for us to understand that 14 church buildings were surveyed for this research. But for the purpose of this presentation and for the paper presentation, we picked two of the church buildings to discuss on, which is the Seventh-day Adventist church building that had no air conditioning systems, and the Redeemed Christian Church of God church building with air conditioning systems. So right here you have the energy consumption data for Seventh-day Adventist church building. Here we took data for the power amplifiers, the loudspeaker, wireless, and the lightings and all those electronic equipment and their sound instruments. On imputing the data into the eQuest simulation software, we got this as the baseline result. Here you have the plug loads represented as miscellaneous equipment, and here you have the area lighting. There was no space cooling, so that is why this graph looks like this. Here you have that the total kilowatt hour was 25.89 kilowatt hour from January to December. This pie chart here shows that the plug loads took 92% of the total generated energy, while the area lighting took 8% of the remaining energy. Now, when we did the first simulation, which was to reduce the lighting power intensity, we had that the total energy reduced from 25.89 kilowatt hour to 25.64 kilowatt hour, which is very little reduction there in the energy consumption. In the annual utility bills, we can also see this decrease, very little also, from $3,000 to from $3,169 to $3,141. Little or significant change, or no significant change there. Then here again in the monthly utility bills, we can also see, looking at the graph here, we can see that very little or no change took place after the first simulation. Also here in the annual energy consumption, we can also notice the same thing in the area lighting. After the first simulation, little or nothing happened. Also here in the equipment, little or nothing happened. But on the second simulation, which was to reduce the equipment power intensity, we saw significant reduction, because we can now see, even from the graph, you can see that this for the first simulation, little or no change here, but on the second simulation, which was to reduce the electric power intensity or equipment power intensity, we can see significant change here, and we can see that here from 25.89 kilowatt hour to 20.79 kilowatt hour, which is about 5 kilowatt hour reduction in energy consumption. Now, this is the Redeemed Christian Church of God. These are the consumption data that we took for the Redeemed Christian Church of God. The same thing, just that for this very church building, we had split ACs, and we also had refrigerator involved. Now, after we imputed all the data into eQuest software for simulation, this is the baseline output that we got. As we can see, this is for the space cooling, and then this is for the plug loads, while the yellow area here is for the area lighting, and the pink area here is for the ventilation fans. Now, total electric consumption was 358.16 kilowatt hour. So bulk of that energy was consumed by space cooling, and 27% of that was consumed by the plug loads, while 5% was taken for the area lighting and 3% was taken for the ventilation fan. Here we can see on the first simulation, which was to reduce the lighting power intensity, we had little or no change, as you can see from the graph here. Still the same thing here for the electric consumption. We can see little or no change. We can see that here it was 358.16 kilowatt hour, and after the first simulation, we now had 355.41, which is just 3 kilowatt reduction in energy consumption. Now, in the annual utility bills, we can also see the same change. We can see that very little change took place from $41,458 to $41,147. Also in the monthly bills, also, as you can see from the graph here. Here we saw little or no change, miscellaneous equipment little or no change, space cooling little or no change after the lighting power energy intensity reduction. But here on the second simulation, which was to reduce the equipment power intensity, it is obvious that there is significant change, as you can see here, from 358.16 kilowatt hour to 321.17 kilowatt hour. Even on the graph, it's obvious here. On the first simulation, little or no change, but on the second, we can see a lot of changes here. We can see significant change here and all that. Even in the annual utility bills, we can see that there's significant change also in the cost of energy consumption. We can see from $41,458, we now have the cost reduced to $37,027, which is very significant. Now we can see the monthly bills also, it has been affected. We can see the reduction there. Here we can see reduction, we can see reduction here, we can also see reduction here at the space cooling. And here also, it's very obvious here, annual electric consumption, we can see no significant reduction here, but very significant reduction here. Now to conclusion. We discovered that some of the factors responsible for current energy performance of the church buildings were the use of fossil fuel generators as last resort for energy generation by churches due to the epileptic supply of power from national grid. Also, that the absence of energy codes and regulatory policies on the energy consumption and performance of church buildings was a factor. And then that poor management of generated electricity by the church management and members of the respective churches also accounted for this. Then another factor was the lack of awareness of the church body in Nigeria as a whole towards the mitigation concerns for these greenhouse gas emissions and their green alternatives such as the popular solar power. In conclusion, an average church building in Nigeria relies heavily on the use of fossil fuel generators as a major source for self-generated electricity. On the average, according to the eQuest software, church buildings in Nigeria consumes between 25 kilowatt hour to 358 kilowatt hour of energy annually. a range of value that depends on the church dynamic facility needs. We conclude that green energy alternatives, the more cost-effective alternatives, will definitely reduce the energy consumption in church buildings in Nigeria. Contributions to knowledge. This is a novel research on the energy performance of church buildings in Nigeria. This research provides a benchmark for further studies on the energy performance of church buildings in Nigeria. And finally, this research provides data for design considerations for church building teams. Thank you very much for listening.